Hello, my dear friends. I'm Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE chemistry chapter number 2, chemical bonding, and so far we have covered the ionic bonding and covalent bonding in previous videos. So if you have missed those videos, please do watch, because those are the basic concepts. If you would understand those concepts, it would be easier for you to understand coordinate bonding, which we are going to cover in this video, and we are going to cover all the concepts of coordinate bonding. Okay, and after that we are going to solve some questions. So without wasting much time, let's start and let's rock. Okay, now let's start from the basics of coordinate bonding. Okay, so let's start from the word coordinate bonding itself. We will just remove that ing, then what would remain? Coordinate bond would remain. And yes, let's start understanding what does this coordinate bond mean. Okay, so we have already studied, when we were studying ionic bonding and covalent bonding, I have already told you that this coordinate bond is also a type of a chemical bond, right? So it is a chemical bond. Now this chemical bond is formed, it's also formed between two atoms. Okay, very fine. Now what's different in this type of chemical bond? Okay, this bond is formed between two atoms by sharing a pair of electron. Okay, now you would say, what's different in it? Covalent bond is also like same like this. The chemical bond is formed between the two atoms, right, by sharing a pair of electron. But in covalent bond, the sharing is mutual, right? I have already told you the meaning of this word mutual, which means if the bond is formed between A and B and they are sharing one pair of electron, then this electron is being contributed by this atom, this electron is being contributed by this atom. But here in coordinate bond, what is happening? It is also getting formed between two atoms, okay, by sharing a pair of electron, but this pair of electron is provided entirely by one of the combining atoms. Okay, so this means this shared pair of electron, okay, this pair of electron is being provided by A only or B only. Okay, so here suppose it is provided by A only. So what B is doing then? Oh, B is like just sitting there and just accepting that shared pair of electron, or just taking up that shared pair of electron and sharing it with A again. Okay, so this type of bond, which is formed between the two combining atoms by sharing a pair of electron, okay, but this pair of electron is provided entirely by one of the combining atoms, and such bond, when it is formed, this bond is called as coordinate bond. Okay, very interesting, right? So something, a twist in the story, right? We have studied ionic bonding, we have studied covalent bonding, but this is like kuch to naya hi hai hum, right? Now H3O plus and NH4 plus are the examples, because in this species you would find the coordinate bonding. Okay, don't worry, we are going to learn in very much detail how the coordinate bond is formed in this species. Okay, but before that, let's first understand one more basic term. Okay, so that we would clearly understand the process of formation of coordinate bond, and that term is lone pair of electrons. Okay, now hearing the word lone, you would get into that lone, L-O-A-N. No, that lone is different. This lone is like, you can remember like this. The alone, from alone, you just shift this A out. Okay, you would just shift this A out, what would remain? Lone. And the meaning is also same. Okay, you would figure it out right now. So what actually lone pair of electrons is? It's a pair of electron. Okay, from its name only we can judge, we can guess it. A pair of electrons, okay, which is not yet shared with other atoms in covalent molecule. Okay, now I think it would be getting over your head. Okay, let's take an example so that we could understand. See, I have this covalent molecule, water. Okay, now I know we have studied the electron dot structure, so I'm just drawing the electron dot structure. Okay, here is the oxygen's atom, here is hydrogen's atom which is being shared. Okay, and here are the two pairs of electrons. Okay, one pair and two pair of oxygen atom. Now see, these two pairs of electrons, okay, which are not yet shared with other atoms, okay, in a covalent molecule. See, water is a covalent molecule, and these two pairs of electron are called as lone pair of electrons. Very clear. Okay. Now moving ahead, we are going to study the coordinate bond which is formed. Okay. Very simply, we are going to study the coordinate bond which is formed between an ion, okay, in this chapter, which is formed between an ion and the atom of polar covalent molecule having one or more lone pair of electrons. Okay, now let's simplify it. So what actually we are going to study is, we are going to study the coordinate bond which is formed between an ion. Okay, so here in this case H plus ion, okay, is the example. So coordinate bond formed between H plus ion and the oxygen atom. Okay, oxygen atom of, see, ion is H plus, atom is oxygen, of polar covalent molecule. Water is a polar covalent molecule, correct? So the bond which is formed between this ion and the atom of the polar covalent molecule, okay, so this bond is coordinate bond, and we are going to study this type of bond, okay, which is formed between ion and the atom of polar covalent molecule. So same way we can also see about NH4 plus as well. Okay, so here suppose this are the 3 hydrogen atoms and nitrogen atom. Okay, now we are going to study the bond, the coordinate bond which is formed between the H plus ion, okay, and the atom of polar covalent molecule, which is here in this case nitrogen atom of the polar covalent molecule ammonia. Okay, so we are going to study the coordinate bond formed between this H plus ion and the nitrogen atom of the polar covalent molecule. Now comes the last term, which is having one or more lone pairs of electrons. That's why we studied what is lone pair of electron. So see here nitrogen is having one lone pair of electron. At least it should have one lone pair of electron. Okay, oxygen is here is having 2 lone pairs of electrons. Okay, now why it should have one lone pair of electron, at least one, we are going to see it in next slide. Okay, now let's see the formation of hydronium ion and hydroxyl ion. Okay, H3O plus is hydronium ion. We'll write it here. Okay, and OH minus is hydroxyl ion. You would be knowing, okay, about OH minus. Now, these 2 ions are formed in water. Okay, and now how these 2 ions are getting formed, we are going to study this. Now, during the formation of H3O plus, we are going to also study how the lone pair effect is working of oxygen atom. Okay, and that's when you would understand what I was saying before, that why the lone pair of electron is necessary, okay, for the formation of coordinate bond. So let's start. First, what we would do, first we will see the formation of OH minus ion. After that only we could understand how H3O plus is formed. Okay, so for that I am having a water molecule. I am drawing its electron dot structure. Okay, so these are the shared pairs, these 2 are the lone pairs. Now what is happening? Water is getting ionized. Water is getting ionized means water molecule is getting converted into ions, right? This is what ionization is, right? We have studied in covalent bonding. So which 2 ions it is getting formed? Now we would understand this thing. See, we already know it forms in H plus and OH minus ions, but how it is getting formed? See, here this water molecule is asking this hydrogen, okay, that you just leave without your own electron. You don't take up your own electron. This is X1. You don't take this electron. You just leave it. Okay. You just leave it, and what then it would form? See, since hydrogen is deprived of its one only electron, what would happen? It has now, we can say, lost its one electron. After losing its one electron, it would form H plus, right? So it is forming H plus ion. And what is now case with this O and H? Okay. This oxygen and hydrogen, they are having their shared pair, okay, intact. The lone pairs are also intact. Okay, but now see here, this electron is of oxygen, but this electron was of hydrogen, right? Now this oxygen has gained up an electron. Now what we say, when an atom is gaining an electron, it is forming an anion, right? It gets a negative charge. So same way oxygen also gets the negative charge because it is gaining the electron of hydrogen. Now since oxygen is getting the negative charge, now what we do is we put this negative charge entirely on this OH, okay, OH ion, and then we say this as OH minus ion, okay, hydroxyl ion, okay, because of the negative charge which is getting on the oxygen, we are showing it on the entire molecule itself. Okay, and this forms our hydroxyl ion, OH minus ion. Correct? How it is getting formed? Now comes the story for the formation of H3O plus. Now we are having another water molecule. Okay, the same way I'm going to draw its electron dot structure. Two lone pairs. Okay, two shared pairs. Now comes the role of the lone pair. Now this lone pair of oxygen, one of the lone pair of oxygen atom, okay, what oxygen atom does? It uses its one of the lone pair, okay, and it shares this lone pair with this H plus ion. Okay. Now since the shared electron are provided entirely by one of the combining atoms, right? And the another atom is just accepting the electron and then it is sharing back the electrons, okay, with the previous atom. So what is going to be formed? Coordinate bond. Just now we have studied, right? And yes, this way what happens is, see here, this hydrogen and oxygen bond, this hydrogen oxygen bond is intact. This lone pair is also fine, but now here this lone pair is getting shared with the hydrogen H plus. Okay, now what is happening? See here, hydrogen is now getting very much happy because now it has 2 electrons in its duplet. But see here, for the oxygen's case, you would say that, see, 1 2 3 4 5 6 7 8 8 electrons are there with oxygen. Oxygen is also happy. No. Have a closer look. What is actually happening is, this electron is still with oxygen, but now since this electron is being shared, right, the another electron is also being shared. So now this another electron is in close vicinity towards the hydrogen. So what we can say is that what is happening, oxygen has almost lost its electron, almost. So what happens when an atom loses an electron? Okay, it gets a positive charge. So here oxygen gets a positive charge, and that's why we show this positive charge entirely on this H3O. Okay, and it forms an hydronium ion. Okay, now this is the electron dot structure of hydronium ion. Okay, when they are asking you in examinations, you have to draw this structure, but along with it you also have to draw the bond structure as well, because your examiners want you to show the coordinate bond. Okay, the coordinate bond is formed between this oxygen and this hydrogen atom, right? But they also want you to show the coordinate bond, so you have to also draw the bond structure as well. So bond structure is very simple. See, the shared pairs, you know, these are the covalent bonds because the sharing is mutual here between the oxygen and hydrogen. Okay, in the water molecule we have already studied this, so we are going to represent this covalent bond by single lines because they are single covalent bonds, right? Only one shared pair of electron is there. Lone pair, we are going to show it as it is, and this pair of electron which is being shared between oxygen and hydrogen, okay, which is entirely being provided by oxygen, due to which the coordinate bond is formed, we are going to show the coordinate bond with the help of an arrow, okay, in this way, and the entire positive charge as it is. Okay, so you have to draw both bond structures as well as the electron dot structure when you are asked in your examinations to draw the electron dot structure of hydronium ion. Very clear? Now let's see the net reaction. What is happening? See, first water molecule, it got ionized in H plus and OH minus. Second water molecule formed H3O plus by picking up this H plus. So let's try to see the net reaction. See, first water molecule, it formed H plus and OH minus, right? Second water molecule, what it did is, it picked up this very much H plus and then it formed H3O plus. So what would be the net reaction then? Okay, net reaction, when seeing the net reaction, we would just cancel out the species. Okay, suppose the species on the left side of this arrow, okay, this is the left side for me, so left side of this arrow with the species on the right side of the arrow. Okay, so let's do it actually, then you would understand. See, here there is water molecule. Now what I would see, whether in the next reaction on the opposite side there is water molecule or not. No, there is no water molecule. Now since there is no, we cannot cancel anything. Now here is H plus and OH minus, right? Now what I would find is this H plus and OH minus, sorry. Okay, so whether they are present in the next reaction on the opposite side or not. So see, here there is H plus, here there is H plus, yes, so we would cut it out. OH minus, no, OH minus is not present. Same way, here water molecule is there, so you would check in the other reaction opposite side. whether water molecule is there or not. No, there is no water molecule. And then same way, H3O plus is there in this reaction. We would check whether in the previous reaction or the other reaction H3O plus is there on the opposite side or not. So there is no H3O plus. So nothing will get cancelled. So see, now the net reaction would take place. Now the net reaction, we would understand. What we would do, we would just pick up all the molecules which are on this side, okay, of the arrow. So which are the species? Water, okay, pick up all the species which are on this side of this arrow. So water and this other water molecule, that's it. This H plus is cancelled. These are the two water molecules on this side of the arrow, and on that side of the arrow, what are the products? H3O plus and OH minus. Okay, now you can see here a magic. See, water, okay, water molecule is getting ionized, right? It is getting converted into ions in the presence of another water molecule. Okay, means like it's a kind of self ionization. This water molecule is getting ionized in the presence of another water molecule. So that's why we say that this is the self ionization of water. Water gets ionized in presence of itself only. Okay, so very interesting thing is this, and based on this thing there are many concepts which are developed. Okay, so no need to get into that detail. Just from this reaction, okay, the formation of H3O plus and OH minus in water, we can clearly understand that water gets self ionized. Okay, so now this was all about the formation of hydronium ion, hydroxyl ion, and we have also studied the lone pair effect of oxygen atom of the water. Okay, and one more important thing, if they ask you to draw the electron dot structure of hydroxyl ion, even if they ask you to draw the electron dot structure of hydroxyl ion, you know now. Okay, so this is the electron dot structure of hydroxyl ion. Okay, now for drawing this, you should know the process, how hydroxyl ion is formed. Okay, for drawing the hydronium ion's electron dot structure, you should know the process. Then only you won't make any single or silly mistake. Okay, so you have to take care of the electrons, the symbols of the electrons. Here see, the electron of hydrogen is there, okay, with oxygen, so it should be denoted with X in the same way. Okay, so don't miss out anything, and I definitely know you won't miss out if you know the process of the formation of particular molecule or particular species. Now moving ahead, let's see the formation of NH4 plus ion. Okay, this is called as the ammonium ion. Okay, now in this we are going to see the lone pair effect of nitrogen atom. So how the ammonium ion is formed? Now we know how the hydronium ion is formed, so it's now easy for us to understand this. So see here, first, now I would draw the electron dot structure, okay, not the bond structure directly. So this is the ammonia's electron dot structure, we know now. Okay, and here is the lone pair of nitrogen atom. Now same way the H plus ions, okay, are interacting with the nitrogen atom like the same way they interacted with the oxygen atom. Now in case of oxygen atom, it had two lone pairs of electron. Nitrogen atom has one lone pair of electron, but it's absolutely fine because that what it wants, this lone pair of electron nitrogen wants, so that it could share this pair of electron with this H plus ion and form the coordinate bond, correct? So it exactly does the same thing. What happens is, okay, this NH3, I would draw the electron dot structure as it is, okay, and this lone pair electron of nitrogen is getting shared with the hydrogen. Okay, now what is happening? The same case, since we can see here hydrogen has attained duplet, okay, it's happy. Nitrogen's case, 1 2 3 4 5 6 7 8, you would be able to see that it has 8 electrons, but this electron is now, one electron is in its own vicinity, okay, is in its own vicinity, but the another electron is like slightly towards the hydrogen, okay, it is in vicinity of hydrogen. So we can say that nitrogen has almost lost that electron, and that's why we know when an atom loses an electron, it gains a positive charge. So that's why nitrogen also gains a positive charge, because it has almost lost the electron. Now since this positive charge is there on nitrogen, we show it on the entire species, okay, in this way. And this is the electron dot structure of NH4. Okay, so while drawing the electron dot structure, I have told you in examinations you have to also draw the bond structure as well to show the coordinate bond. So bond structure would be easy now for you. Single bond, between nitrogen and hydrogen. Now you know this thing, single bond between nitrogen and hydrogen, and single bond between this nitrogen and hydrogen. Okay, these two electrons are being showed with the coordinate bond arrow. Okay, the coordinate bond is getting formed between nitrogen and hydrogen, and in the same way the positive charge. Very clear? Okay, now let me tell you a interesting thing about this NH4 plus. Okay, this NH4 plus, when it comes in interaction with the Cl minus, okay, so this is the positively charged ion, this is a negatively charged ion. What would happen between them? Try to recollect the ionic bonding. The strong electrostatic force of attraction would develop, right, between them, and they would form an ionic bond and an ionic compound. So ionic compound NH4Cl is formed. Okay, now why I'm telling you this thing? Because this is very interesting to know that this compound has all the three types of bond which we have learned so far: ionic bond, covalent bond, coordinate bond. How? You can pause this video and then try to find out on your own. Okay, after resuming back, let's see how it has all the three types of bond. Just now we have seen, see this NH4 plus, okay, NH4 plus, this NH4 plus and Cl minus, it is existing like this. Okay, so this NH4 plus has coordinate bond, covalent bond, right? So two bonds are done here only, and between NH4 plus and Cl minus there is ionic bond. So see, there are all three types of bonds present here. Okay, now we have reached the end of the electron dot structures. Okay, we have studied all the electron dot structures which we have to study in this chapter. Now let me tell you an interesting trick, okay, so that you won't make any mistake while drawing the electron dot structure. See, I have always emphasized on the process of formation of particular molecule or particular species, right? You have to know the process of formation, then only you would draw the right electron dot structure. So what you can do in examinations, when they ask you to draw the electron dot structure of any species, you just write in the form of equations, okay, in this way, the process of formation of that particular species, okay, whether it be a chlorine molecule, nitrogen molecule, or NH4 plus ion, or anything, okay, NaCl. What you have to do just is, you have to just write with the pencil the entire process of formation. Then you would ultimately reach the electron dot structure. Then you rub the process and you just make it final with your pen or something else with your pen, so that electron dot structures would be like very much correct. Okay, you won't make any mistake because you have followed the process. Okay, now seeing the last topic of this entire chapter, conditions for the formation of coordinate bond. Now it would be a piece of cake for us to understand this thing, because we have because till now we have understood entirely how the coordinate bond is formed. So first condition is atom must have at least one lone pair of electrons. We have already understood this thing, right? If the lone pair of electron is not there, then that atom cannot entirely provide a pair of electron to the ion, so no coordinate bond would be formed, right? So this is a very important condition. Next condition is the ion should be short of at least a pair of electrons, right? We have seen H plus in both the cases. This is short of a pair of electrons. Just it wants 2 electrons, it would be attaining a configuration of helium, it would be very much happy, right? So these are the two very much easy conditions. Okay, now lastly, coordinate bond, we have just now studied the formation, and what we have figured out. See, when the coordinate bond is formed, okay, what is happening? The electron pair is being shared, right? So it is having some of the characteristics of covalent bond, right? Now at the same time, this electron pair is being provided by one of the atom. Okay, since it is being provided by one of the atom, so is it having some property of transfer of electron, right? It is being provided by one of the atom. Just like in the case of ionic bond, the electron is being provided by one of the atom only, right? So the transfer like property is also there in this coordinate bond, okay, which is like that of the ionic bond. Okay, so this means that our coordinate bond has properties of both ionic and covalent bonds, correct? There is some sharing of electron as well, there is some transfer of electron as well. Means transfer of electron is also taking place, sharing is also taking place. That's why we call this coordinate bond as co-ionic bond. Okay, covalent ionic bond. You can remember in this way, co-ionic bond, and it also has another name which is called as a dative bond. Now it's time to see some questions. Okay, so first is draw the electron dot structure of ammonium ion, asked in 2019. We already know, right? Draw the electron dot diagram of hydronium ion. This is the second question. Okay, it is asked in 2018. So you can see the electron dot structures of the electron dot structure of species which are having coordinate bonds are also being asked in the examinations. Okay, and we have already studied this. You can pause here. You can try drawing it on your own and then again resume back. Okay. Next is fill in the blanks from the choices given in the brackets. The compound that does not have a lone pair of electrons is dash. Okay, so options are water, next is ammonia, and last one is carbon tetrachloride. So now it's a piece of cake for us, right? We already know water has a lone pair of electron. It has two lone pair of electrons. Ammonia has one lone pair of electron. Now what they are asking? Compound that does not have a lone pair of electron. So both of them have lone pair of electron. Carbon tetrachloride, see, CCl4. We have studied its structure. Okay, there are simply 4 single covalent bonds between carbon and chlorine, right? So it doesn't have any lone pair of electron. Carbon doesn't have any lone pair of electron. So our answer is carbon tetrachloride. Okay. Next, what do you understand by a lone pair of electrons? Okay, so we have already studied this. I have already explained you what is lone pair of electron. It's simply a pair of electrons which is not shared, okay, with other atoms, okay, in a covalent molecule, right? Very simple. We have also studied, we have also seen the example. We have seen entirely its effect as well in case of oxygen atom and nitrogen atom. So we have reached the end of this video and we have learned all the concepts of coordinate bonding, right? So I hope you would have enjoyed learning with me. You would have understood all the concepts, but please do let me know in the comment section whether you have enjoyed, whether you have understood the concepts or not of coordinate bonding. And as you all know, LearnoHub matlab free hai par best hai. So stay tuned. See you in the next video with the next chapter. Till then, bye bye and have a great day.